Hello everyone, we are from group 24 and our BTech final year project is pizza image based calorie calculation. So our group members include Suyash, Sayan, myself and Pranav, and our guide is Kalyani ma'am. So let me begin with the introduction of our project. So in today's world, the problems that people are facing is changing drastically. As we know that there's a rising concern of health issues which a lot of people are facing, and according to WHO, 39% of adults above 18 were considered overweight and 13% of them were considered obese. And as you can see, this is not a very good trend for the humanity. So for trying to combat this, we have developed our project in keeping this in mind. So our project is capable of recognizing pizza images and calculating the approximate amount of calories that it contains. So by getting this amount of calories in a quick and accurate manner, people are going to be able to make a more healthy choice and lead a healthier lifestyle. So keeping this in mind, let us move to the problem statement of our project. So we are trying to calculate the number of calories present in the pizza image while also accounting for the various toppings present on it. So any toppings including paneer, chicken, onion, tomato, all of these would be considered annotated and would be added under the total sum of calories. So the input for the program would be the set of images of pizza, and each of the images would have different topics present on it, and that would be used for training. And our model would be very robust in training on the images and on trying to calculate the volume of the pizza. Calculating the volume is very essential and is a very major point through which we are able to get a very accurate estimate of calories. And also we will be using a small unseen set of images for testing our model as well. So moving ahead, these are the objectives. So as I have mentioned, it is estimating the calories on the different types of pizzas and different types of toppings, and also trying to minimize the error of our predicted calorie value. So from here, Pranav from my team would be taking the next part.
Yeah. So thank you, Sharat, for such a wonderful introduction. So these are all the research paper which we have referred for our project. Next slide. So there are some research gap. Till now, there is no such research paper which tells us the calorie of pizza. Yes, there are some research paper in general area of calorie estimation, and our main aim is to give the accurate calorie for pizza. We are also considering the topping of the pizza. So we have created our own data set by using image CV and BCG annotator. So we have segregated images into three sessions: training, testing, and validation. So training we have images almost 3000, testing we have 890, and validation we have also 304 images, and the total image count is 7230. After pre-processing, our images number of images has become to 7000. From now, Sayan will continue.
Thank you, Pranav. Next, I'll be explaining the system architecture. So first, we needed some data to fit the Mask-RCNN model for image recognition using deep learning. So the data which is given as input first has to be annotated with boundaries and classes for each of the toppings in the pizza. So to identify what is on the pizza, we needed to instant segment the given pizza image into possible topping categories. So given the problem of instant segmentation, the architecture of Mask-RCNN would be a matching solution. So we selected Mask-RCNN as the instant segmentation approach for our project. So Mask-RCNN will take an image and split it into three outputs, that is mask for the identified toppings along with its bounding boxes and classes for each of the mask detected. Next slide. So after acquiring the pizza object along with its mask, we needed a foolproof plan to estimate the size of the identified toppings too. So to acquire the topping size and thus estimate the calories, we needed an object size estimation approach. Estimating object size through a single view camera task is a very tricky job. So a reference object is needed for size approximation without using multiple view camera. So as the same food can be taken at different depths to generate different picture sizes, we needed a method to calculate calorie or estimate the size of the toppings in real world scenario. So after we get the desired food items detected along with their mask, we needed the real object sizes, which is not possible through a single view camera alone. So we take a referencing approach that references the toppings object to the size of the pre-known object to extract the actual size of the toppings. So we propose to use a coin as a reference object for the estimation of the food detected in the image. Coin can be easily detected using the edge detection using the Mask-RCNN approach, which we have included in the training images to detect along with the toppings with a single network. So after we detect the coin, the pixels per inch square is calculated using the actual size of the coin in real life. So pixels per inch square is given by the coin pixel area divided by the actual coin area, and the real food area, that is the toppings in the pizza area, can be calculated by the ratio using masked food pixel area by pixels per inch square. And then we will calculate the total calories by adding all the toppings calorie plus the pizza base calorie, which will be calculating using this formula. So after detecting the calories, we need a simple CSV that we have created for the toppings in the pizza. So the CSV will contain the calorie information for each piece, gram, cup and ounce, which will be mapping for each topping to its calorie value. So we'll be counting the number of topping items wherever obtaining the count is possible, and we use the outputs from the Mask-RCNN model to implement the simple algorithm to determine the calorific value using simple lookup on the CSV file. Next slide. So these are the hardware and software specifications. We have conducted all the experiments in Google Colab. As we can see that Google Colab is a very good option for deep learning. As our task is more memory consuming, so Google Colab is the right choice because it has almost about 12 GB of RAM, and Google Colab is also offering two different types of GPU models, K80 and T4. However, we cannot select the GPU due to the availability issues, but each user will get limited quota for the T4 GPUs. This means having nice GPU in Google Colab is not always guaranteed, but Google Colab's GPU with higher memory clock will obviously deliver better performance for deep learning. Now my team member Suyash will explain further slides.
Thank you, Sam, for the explanation. So now I will continue. So these are the result parameters that we got from our model. So for precision, we have got 96%. For recall, we have got 51%, and for F1 score, we have got 67%. And we have also calculated the mean average precision. The normal mean average precision is 93%, and for the IOU of value of for 50%, we have got 91%, and for 75% of IOU, we got 87%. Next slide. So this is the result we got when we pass image to our model. We are giving coin as a reference object, as you can see in the image, and it is also detecting the coin. The model is predicting the toppings accurately, and some of the toppings which is very small and or it is covered in cheese is very hard to predict for our model. So yeah, the next slide. So according to the area, we are calculating the calories for each topping. We will calculate the calorie, and finally we add those calorie to get the total calorie. As you can see, we have got 573 point, like that value. Yeah, next slide. So based on the calorie result that we have seen in previous slide, we are plotting the pie chart of all the values. uh, as you can see. Next slide. Yeah, so this is the graph of training loss and validation loss. So as you can see, for each epoch the error rate is reducing, and after we reach certain number of epochs we get straight line. uh, so you can see we have stopped at value 80. Yeah, next. So for future scope, the model can be further enhanced to work for broader set of images and more accurate. And we can also add a website where we can give uh, real-time images to the website, and it will predict the total calories. And next slide. And these are the reference websites where we have taken some of the information. Now Sharad will show you the code from Google Colab.
Thank you, Suyash. So let me just show you the code. So for our model, we have just done the training, and as you can see, each epoch was taking about 10 minutes of time. So the results of the training were this. So whenever an image is given, the coin would be first detected, and after detecting the coin, the reference could be easily generated. And all of these marks have been generated, and as you can see for this image, this is a chicken pizza, so all the toppings are of chicken. And let's move to the further images. Since there's a lot of toppings on this one, they're a bit overlapping in the text, but let me just read out some for you. It's tomato, red pepper, onion, and paneer. So this is also an example of how the model is able to get a good amount of masks and a good amount of mask in this image as well. So these are a few of the calculations which we have done. So calorie per inch square, as San had mentioned, these are the values which we have gotten, and this was the output that we had shown you in the previous slides. So this was the 573 calories for that pizza, the pie chart as mentioned, and these are the results. And this was the training and validation loss graph. So that is about the demo of a project. Thank you.